Hello, this is Anuj Antony. You are 15 CS 170. So today I'm with my 8th video of data structure. So today I have to do the implementation of merge, sort and quick sort. So here's my first program of that merge sort. So in this program I use a header file as iostream and conio, and using namespace std is a standard standard library function. So in this program I used a two function, like first is merge sort and second is merge. So in the merge sort, I declare some variable like low, high, and a. So in the merge sort, I need the variable as mid value. So I'm declaring mid of n type. So then I'm checking the condition. If low is less than high, then the mid value we need. So mid value is calculated by the low plus high, the first plus last divided by 2. So we will get the mid value. Now we will merge sort. So the low and the mid, first value and the mid value up to there, and the sorting will be done. The second step means it will start from mid plus 1 to high. Means mid plus 1 to high it will sort, and the large it will merge low, high, and mid. So it will return that. Now we can see the merge part. The merge part also I declare some variable like low, high, mid. So some variables more I, j, k, and c of 50. So I'm analyzing I and k as low and j is equal to mid plus 1. So mainly this merge sorting is a divide and conquer process. So we'll in the merge sort we will divide the array into two parts. Again, if it is eight type of elements, so it will divide into 4 and 4. Again, the 4 will divide into 2, and again the 2 will divide into 1. So it is a divide and conquer process. So as I said, analyze the value, then I will give the condition as I less than, if the I condition is I less than is equal to mid and j less than is equal to high. So if a of I is less than a of j, means the k, if the k and I value will be incremented if c of k is equal to a of I. So if c of k is equal to a of j, that is the high one, the k and j value will be incremented. Here the low is saying that a of I. This is for the mid one. If I is less than is equal to mid, that means c of k is equal to a of I. That is from low to mid. So the value of the k and I will be incremented. So for the high one, that j less than and j less than is equal to high, the c of k is equal to a of j. Then the value of the k and j will be incremented. So here one for loop is there, that I is equal to low, I will be up to k and I plus plus. Then it will compare. Means it will the unsorted array will be sorted. Means the a of I is equal to c of I. So this is a main part. The main part, where I ask the user to enter the elements. So it will store it as a of I, and it will merge sort a 0 to 4. That is, I given the value from 0 to 5. So index, it is short from index 0 to 4. The sorted array is presented as below, that I is equal to 0, I up to 5, I plus plus. So it will just print the array a of I, and enter the element I'm asking the user to print. Then same thing, it will store it as b of I, and the merge sort, that is b. First one was a of 0 to 4, and second one is merge sort b 0 to 4, the index 0 to 4. So the sorted array will be printed as b of I. So here's the output, asking the user enter the number element, enter the elements. So I'm giving as 45, 23, 78, 3, 67. So as you can see, the sorted array as 3, 23, 45, 67, 78. So the time complexity of this algorithm is bingo of n log n. So here's the end of the first program. Now we can see the second program, quick sorting. In quick sorting also I declare some header file, iostream and conio. In this, mainly the quick sort is mainly for the partition type. So it will partition will be handled in the array. So it will compare that first to that last. It will divide, same thing. So here also I declare some variable like low, high, and a. So here the partition function is going on. So I analyze I, H, L, and P. P is pivot, which we mainly used in quick sorting, the partition technique. So here condition is there, the while low is less than high. So if a of L is less than p, the L value will be incremented, the low value will be incremented. And if a of h is less than p, that is high, then the high value will be decremented, then only it will be shorted. We will compare. So if low is less than high, that is L is less than high, this means the swapping will be done. Mean that and this one sorted and unsorted array will be swapped between them. So just swapping code, or else if not, it will follow this step. P is equal to P, P is equal to A of L, and A of L is equal to T. So it will return. Now this is a quick quick function. Here also some variables are there, L, H, and A. So if L is less than H, this thing, the following code will be performed, that the index is equal to partition of that L, H, A, that is low and high. So the quick will be that 1 comma index minus 1 A, the quick index plus 1 H, it's high. So here's the main part. The main part also some variables are there. So I'm using the enter the asking the user to enter the number of elements to store at n, and it is elements for the space separator. We store it as a of I. The initial array will be printed like this, and after the sorting, it will print it as a of I. The array will be printed. So now we can see the output. So as it asking enter the number of elements, so I'm giving as 6. So enter the elements I will keep 23 something, 78, 13, 56, 2, and 4. So as you can see, the initial array was like that, and after sorting it will be sorted 2, 4, 13, 23, 56, 78. So in this quick sorting, the complexity is n square. We go of n square. So is the end of the program. Thank you for watching this video.